evening. My name is Klase. I've been collecting radios for about 10, 12 years now. My background is repair technician in the past and engineer since then. I primarily like the technological aspect of the hobby. I collect shortwave sets, communication receivers, etc. Let's start out by considering what is the most magic thing about a radio? Come on, what is it?
Memories.
That's it. That's it. The radios play. They suck voices and music right out of the air, sometimes from halfway around the planet. And it's important to me to hear a radio play, to find out how it works when it was originally sold and originally used. Let's consider the other part of this, restoration. When you're dealing with a relatively young piece of electronic equipment, 10-year-old radio, thing stops playing. You go in, use signal tracing to find the bad stage. You do voltage measurements to find the bad component. You replace the component, the set comes up, and live happily ever after. In most cases here, we're dealing with electronic instruments that are more than half a century old. And to really get them to play right requires measures basically different from your troubleshooting and repair techniques. Talk about philosophy. This is my philosophy. Maybe you won't like it, but this is pretty much it. Let's make the step work like it did when it was new. And let's make it stay fixed for a while. Probably on to the next century, I think we can do that. Point here, sometimes when I start working on radio, I say, gee, am I committing some sort of faux pas here by tearing parts out of this thing, by making it somewhat different than the way it came out of the factory? My answer to that is most of the sets we're talking about here are not that rare. A radio that doesn't play is pretty uninteresting, and the Smithsonian guys will save some of them in their original condition that don't play. So how do we do this? In many cases, it's by doing a shotgun job of the thing, replacing a lot of parts without even worrying about whether they're really bad or not. Substitution with modern parts, we're talking here primarily about capacitors and to some extent resistors. I like to not tear things up in terms of how they were wired, what kind of craftsmanship went into the set. And I'll show you some techniques to achieve that. And I've come around to believe that modern components that are hidden below jack in a radio are perfectly acceptable. So I don't spend time pulling the insides out of capacitors and touching new capacitors inside them. Now, radios I'm primarily talking about here are ones of the golden era, let's say the 30s, and 40s, and 50s. And as opposed to earlier radio sets, we see some problems developing as the radios become more complex. Primarily, a greatly increased component count, which drives the reliability down at an alarming rate. And it was the early state-of-the-art to much of this thing. There was no concept of long-term reliability and a lot of things that weren't known about material science. So a lot of these components just weren't going to last half a decade. And a lot of this stuff you'll see dead, dried up electrolytic caps, leaky paper caps, resistors changing value, and other materials like some of the plastics, rubber insulation on wires and whatnot, just coming apart completely. These are the problems we have to face. To look at that in another way, here's a typical battery set, Atwater Kent Model 30. It's transformer coupled from one end to the other. There's one high-value resistor in here, Ridley, and there are two things that you'd recognize as tubular capacitors here and here. This is about, what, 1928 or thereabouts, when 728. In 10 years, we progressed to radios that look like this. This is a 12-tube Zenith from 1938, and the one I have is in a Walton's case. I've circled the caps in red, circled the resistors in blue. Any one of those parts would be out of tolerance enough to make the set not work right, and in many cases, the vast majority of them are in that condition. So, going into this set, determining that that capacitor is short and replacing it, the set sort of plays. A couple of days later, it goes dead further. It's a waste of time, and there's ways to solve the problem. I'm going to digress just a little bit, talk about the order that things happen in here. Visual inspection of the radio is probably the first thing you do when you get one. Hopefully you do it before you buy it, so you don't find yourself in big trouble. Of course, some sets are so you fall in love with them, it doesn't matter. But you're looking for gross damage, missing parts. One of the bugaboos of communication receivers is the ones that have been modified to cause a lot of trouble. And what I call irreparable cosmetic problems, you have broken dial glass that has the dial scale screened on it or something. It's real difficult to deal with that stuff unless you know where there's parts. And there's the other half of visual inspection. After it's too late, you own it. But you look around, looking for burned components, physically leaking capacitors. The one I just read is the broken band switch in an all-wave set. Could be a real problem to fix up. Okay. Once I've decided to restore a set, the first thing I pay attention to is the power transformer. It's probably by today's prices, what you pay for replacements, it's probably the most expensive component in there. Don't just plug it in and turn it on. It's unusual that you'll burn up the power transformer that way, but if you do, you've bought yourself a lot of trouble. I'll show you here in another couple of slides a good way to check the transformer. I'd like to know I have a good transformer before I get real involved in restoring the set for the above-mentioned reasons that you might be able to blind the alley. The other thing that I think is a good idea to preserve the transformer and the rest of the set is install a fuse. Very few of the radios in this era were fused. Maybe before the war, it was almost unheard of. You can install one of the little clip-type fuses, the little bait-like bases you can buy at the Radio Shack inside the chassis somewhere, close to where the power cord comes in. There's always the problem of choosing a reasonable value for the fuse. I'll give you a little bit of a formula here. It's going to be on the order of an amp or two, maybe as little as half an amp in a small set. The message is don't put a 10 or 20 amp automotive fuse in the fuse clip because it won't be very good. Okay, the old transformer test. I said don't turn the set on so you don't burn it up. This is the way to do it. Pull the rectifier tube out, which means there's no load on the high voltage windings. Turn the thing on. If the pilot lights, the tubes don't come up real quick, turn it back off. And when you do have pilot lights, you then know you have your filament voltages. Go in with your multimeter to the tubes, to the rectifier tube socket, and at that point you can measure the high voltage, typically both sides of the center cap of the high voltage transformer. And you can also read the filament voltage to the rectifier at that point. At this juncture, you know you have a good power transformer in the set. You don't have to worry about that too much. A couple more minor digressions. I hate cleaning, but you kind of do it as you go. Does everybody know about Gojo? No?
Best furniture cleaner in the market.
Yeah, Gojo, waterless hand cleaner, a la auto mechanics. Comes in a little tub. It'll clean all kinds of things. Wooden radio cabinets, metal parts, front panels. It's especially good on knobs. Don't use Windex 409 or any of that kind of stuff on Bakelite knobs. Gojo's magic. Don't use the water-based stuff on Bakelite. If you like cleaning dirt off the Bakelite, you're really cleaning the top layer of plastic off it, and away goes the finish. And be careful with the dial scales. You go in trying to wash those or something, you may wash the numbers right off it. You're in big trouble. So a lot of care needs to be exercised there. Lubrication's worth doing. Capacitor bearings, oftentimes have grease on the little ball bearings in the front of the tuning capacitors. Get some fresh grease in there, the whole thing will work a whole lot better. A lot of times things like pulleys on the dial boards, various shafts will be frozen. A little light oil, maybe a little WD-40, take care of those things. I like to use TV tuner cleaner on band switches and the volume control to get at them. Also, tuning capacitor ground connections. There are little spring guys that come out, hook onto the shaft of the tuning capacitor, squirt a little bit of tuner cleaner on there. Try not to get a lot of tuner cleaner on the capacitor plates, so you pick up dust and cause trouble later on. Okay, now let's get down to some electronic stuff here. Electrolytic capacitors, big fat guys in cans. Replace them all, get them out of there. They're old, they've leaked. If they short out the ones in the power supply, they can rip the power transformer right out. Take them out. You'll find these caps in the power supply filters, and there will probably be one cathode bypass in the audio stick. Oh, I didn't say, you probably want to find a schematic for the radio you're going to work on. If you're good, well, maybe you don't need the schematic, but maybe you do. A lot of these are in metal cans mounted above the deck of the radio. Leave them right where they are. Go underneath. Cut the leads free from them. In a lot of sets that have all been repaired in the past, you'll find axial lead, wire lead caps under the chassis, wired in parallel with the old caps. That's kind of dangerous practice, so you want to disconnect all of that stuff. Install some terminal strips in there so you don't have flying connections on your capacitor leads, because the electrolytics are on the heavy side. You want to give them a good place to put them. And don't go overboard on putting larger electrolytics in, electrically larger electrolytics than the ones that were originally in the radio. We'll talk about that a little more in a minute. Here's a typical power supply. Actually, this is atypical of a broadcast receiver. There's 2 inductors and 3 caps. Usually it's about that much. To recap the transformer test scenario, if you pull this tube out, you have a little danger of burning out the transformer. You can measure half your secondary voltage there, the other half there, 5-volt voltage here, and your pilot lights or your tube should tell you your 6.3 is okay. Replacing these caps, because if that one shorts, it's a dead short on the transformer. This is the one you don't want to make oversized. Typically there'll be a value like 8 microfarads. You go in there and put a 47 microfarad cap in there, the system voltage in the radio is going to go up probably 50, 60 volts. That's a good idea. The radio will still play. It on balance is a lot of stuff, and probably puts extra stress on the components. The other thing you sometimes find is rectifier tubes that are replaced with silicon diodes. That's another bad deal, because that again raises the system voltage 50 volts or more. So get the diodes out, 85Y3 rectifiers are plentiful enough to put a tube back in there. Now we get to the real problem. Paper capacitors. Got some of my stuff here. You know these guys, the ones with the beeswax on them. We'll pass these around. If you're ever unsure about whether capacitor is paper or whatever, saw the ends off and crack the case away, and you can unroll it like this. So these are paper ones. These are the bad guys. One particular one I really like here. There are also microcapacitors in radios, which are these rectangular bakelite ones. They usually don't cause problems. But one of my favorites are these that are found in a lot of World War II military radios. They even say mica mold on them, but they're paper inside. They're all bad. Who is? You want to replace these capacitors with modern capacitors that have plastic dielectrics. For those of you who aren't with me, capacitors are made of two plates of metal, which in this case is two pieces of aluminum foil, and they're wound up with two strips of insulating material. In the early capacitors, paper. The later ones, plastic, usually polyester, which is known as mylar, or perhaps some other material. The mica caps are usually okay, just leave them right where they are. And I try not to mess with any capacitor that's involved in a tuned circuit, because you might not have one of the proper value, or in an oscillator it might not have the right thermal characteristics set. It might not work right. So if that cap seems to be okay, leave it alone. Replace them with quality capacitors. You can go buy new ones that were built on the other side of the Pacific Rim. I like to stick with, sort of traditional tubular caps. Look at the ham test, look at the swap beads, try to find some. If you're unsure about whether they're plastic or not, cut one apart to find out. One of my favorites is the SPRAGUE vitamin Q capacitors. These were made for the military. They're hermetically sealed. There's glass seals on the end of them. They're soldered shut, built to last on into the century after the next one, I'm sure.
Think we ever go bad, or?
Not often. Most the reliability of the modern components is like probably 100 times that of the old ones. Literally. Let's take a look at where these caps are used and what the problems are. This is an IF amplifier. The RF amplifiers and receivers are pretty similar. And you see here you have one tube surrounded by 4 capacitors. That's not counting the ones on tuned circuits in the IF transformer. Plate bypass and screen bypass are at high voltage. They short out, they'll burn out resistors, cause other unpleasantness. Cathode bypass doesn't cause much trouble even if it is leaky, but change it anyway as long as you're in there. The filter capacitor on the ABC circuits is real subtle, real insidious. What happens is these guys get leaky. A lot of times, you put an ohm meter across them, measure about a megohm or so. The series resistance here is probably about a megohm. So now the ABC voltage on the stage is cut in half by the voltage divider phenomenon. So the other place you find these paper caps is as the coupling capacitor in resistance coupling stages. This happens to be a mic preamp, but don't worry about that too much. Let me call your attention to this tube with a resistor for its plate load. This tube with a resistor to ground. That's essentially putting the grid at 0 volts for the purpose of biasing. And then this coupling cap. If this cap becomes leaky, then this voltage goes toward the 150 volts that's over here. This stage is grossly misbiased. It's going to cause distortion, and it may pull enough current that it makes the tube get gassy because it overheats, or burns out your output transformer. Okay, so we're going to change all these resistors, all these capacitors. You saw how many there were at Zenith. It looks like quite a job, but there are some old Indian tricks that make this fairly reasonable. And I have to apologize for the typo on your copy of this slide. Does anybody remember buying replacement capacitors from SPRAGUE? A little box says, "Don't be vague, ask for SPRAGUE." That's 5 caps in it. Also, I'll pass these around. I hope they come back. This box had this little envelope in it containing little wire spirals that are coated with solder and rosin. And so the way you replace the cap is you just go into the set. You don't mess around with these solder joints down here. You just say clip, clip, throw him away. You do this one cap at a time. You don't want to have them all cut loose and try to figure out which end is which. The other thing you want to pay attention to is the band on the end of the capacitor is the outside foil. That will typically be grounded. Some places it doesn't matter. In reality, it probably doesn't matter anyhow. But a properly assembled radio has the outside foil on the caps grounded. So you put your new capacitors in the same way with the band on the ground end. Yes, sir?
Many of the new Mylars don't have a band.
They're not marked? Oh, well. So much for tradition. Okay, but we don't have the Quig connectors from SPRAGUE. So what do we do now? You find yourself a machinist tool called a pin vise. Better hardware stores have these things. They're designed to hold a pin or something small like a drill bit. These are real nice for drilling fine holes and things where you just do it with your fingers. But you take your drill bit, maybe a little bigger than 32nd of an inch, you turn it around the other way so you have a smooth pin sticking out of it. You take your new capacitor, and after a while you'll figure out how much to cut off the ends of it. Now the pin vise has a collet on it, which is a 4-piece thing that squeezes down around the drill bit. You catch the end of the component lead in the collet, and you just twist yourself a pigtail. You don't make it tight, you leave open space in it so the solder will flow in. If you're real compulsive, cut that little straight piece off it. Like the other end, straighten it out once it's in motion. Then you can go into your set. Just straighten out those ends a little bit. Stick a thing like that. And like that. Solder it. That beautiful craftsmanship in here, those little ladies sat there assembling those radios. You haven't touched it. You don't have solder leads all over the inside of your radio. You didn't break leads of other components trying to pull them out of there. And you can put a real dent in a recap job in about an hour. So get a bag of capacitors and pin vise, have at it. You can pass that around if people want to see that. I kind of missed it back there a ways. There were a couple of types of capacitors in this era, paper capacitors that don't seem to go bad, one of which is the dreaded bathtub capacitor. I've got real good luck leaving those in radios. Also, if you're a military guy, the ARC-5 command sets had these capacitors that were in these little round metal tubs. They hardly ever go bad. So somebody did something right in some of these gaps.
Beeswax still?
Do you know who invented PCBs? Do you know the name Reginald Fessenden? Fessenden? Yes. He worked for Edison. He invented the chlorinated oils to build transformers, but the guy was a chemist by training. Don't know. Well, that was the rest of that story. I think I just showed it to you. The other numerous components that cause problems with resistors. However, the resistor problem is not near so epidemic as the capacitor problem. Some radios will have good resistors, some will have tired resistors. The resistance values usually increase. Find yourself a 470K resistor and stick your ohm meter across it. Don't even worry about taking it out of the circuit. If it reads a meg and a half, you've got a problem. And then you want to go in and replace all of those guys instead. The higher values are affected more than the lower values. Spot check a couple of set. Remember that most of these resistors are plus or minus 20% in the first place. So don't expect them to be real accurate. But when the 100K resistor gets to be 160, 180K, get it out of there. Move it in. Yeah. Yes. The Radio Shack half waters work just fine.
Did you say don't disconnect the resistor?
Well, you can, but in many cases you don't have to worry about it. They're almost always going to get higher in resistance. If it reads lower in resistance, well then you can say, well, there's other circuitry that's shorting around it. You know, if you need to be accurate, then you cut one end. But basically they're going to increase. So, like I say, you go to that 470K resistor and it's now a meg, you know you're in trouble. And up with my points, so that's it. Just a few more details. I like to pull all the tubes out, test them, clean the tubes up. You're going to wipe the numbers off a lot of them and have your SPRAGUE ready to transfer the numbers to the base. Look over the line cord. A lot of them are really funky. You can replace them. If things like the dial cord look like they're not going to last, fix it now. Because you can go into these sets and fix them and they'll stay fixed for quite some time. Okay, the payoff here. A lot of these radios, you go in, you replace all the caps, make sure the resistors are okay. You turn that thing on, it plays. And any adjustment it needs is usually pretty minor. And you don't go through the thing of turning it on and having it play. You go get the next day, or turning it on and having it play halfway. You go searching in there for what's causing it not to work right. One of the things you need to do with any of these radios is resist the urge to go in and try to solve the problem by aligning the radio. Old mechanic once told me you can't tune junk. That's real sound advice. And so most of these radios need to be restored electronically. And then